Waves, transverse and longitudinal waves. What are longitudinal waves? What are transverse waves? Compare the waves. Label a wave. Longitudinal waves. You can push and pull the end of a slinky back and forth, and that will make a longitudinal wave. And energy travels from one end to the other. And the coils of the spring oscillate to and fro. So the oscillations or the vibrations are in the same direction as the energy transfer, or in the same direction as the wave. And this is how sound travels as a longitudinal wave. So the hand pushing the waves to and fro is doing the same as the vibrating string or the air. And the coils of the spring show what the air is doing. But it doesn't have to be air, it could be any material, and actually solids work better. So if you put your ear on the table, you can actually hear someone tapping their nails on the surface, even if they're very far away at the other end of the table. So longitudinal waves work using changing pressure. So the areas of high pressure, where the coils are close together, which would be here, and then the areas of low pressure, where the coils are further apart, which is here. So you can measure the length of a wave by measuring the distance from one point of high pressure to another. So from there to there. We're now looking at transverse waves. So you do the same with the slinky spring, except this time you move the slinky spring up and down. So you wiggle the slinky spring up and down. And that means that the vibrations are actually at right angles, because the vibrations are up and down. They're at right angles to the way the wave is actually transferring the energy. So right angles. And this is actually how light travels as a transverse wave. So the wavelength is how long a complete wave is. So on this one, it would be from the same point all the way to the same point again. So you can do peak to peak or trough to trough to find the wavelength. And we can alter how high we move the wave up and down, and this would alter the amplitude. So if you put your slinky spring really high up and down, that would be a high amplitude. If you only wiggle it up and down a little bit, that would be a low amplitude. So there are some similarities between longitudinal and transverse waves. They both carry energy. They both have a wavelength that can be measured. They both have a speed that can be measured. And we can count how many waves per second leave one end. This will give us the frequency. The differences are, the main one is the way that energy is supplied at the transmission end. So in the longitudinal wave, the vibrations are in the same direction as the energy transfer, from left to right. Whereas in a transverse wave, the vibrations are at right angles to the direction of energy transfer. Remember that longitudinal waves is an example, a sound wave is an example of a longitudinal wave, and light waves are an example of transverse waves. So now, if we look at some oscilloscope traces, so if it has a low amplitude, so the height of the wave is very low, that would mean it's a really quiet sound. If you have a high amplitude, so the height of the wave is really high, that would mean you have a really loud sound. And then frequency, if you have a low frequency, that means you have a really low pitch. If you have a low frequency, so if there's hardly any waves per second, you would have a low frequency. If you have a high frequency, that means you have lots of waves per second. And it would sound like this. You'd have a really high pitch if you had a high frequency. So if we compare waves now, so you start off with the original wave. This is a pure wave made by a signal generator. But then you want the same sound as in A, but with a higher pitch. So pitch is frequency, so you need more waves per second. The same sound as an A, but a lower pitch, so less waves per second, less frequency. The same sound in A, but quieter, so the waves aren't as tall. The same sound in A, but louder, so the waves are taller, the amplitude is taller. So in summary, waves transfer energy. Longitudinal waves vibrate from left to right, and an example would be sound waves. Transverse waves vibrate at right angles to the direction the wave is moving, and an example would be light. Frequency is the number of waves per second. The pitch is how high or how low the note sounds. Wavelength is the distance between the start of a wave and its end, and you can measure it from peak to peak or trough to trough. Amplitude is half the height of a wave. So here's some questions. So what do waves do? They transfer energy. What is the difference between a longitudinal and a transverse wave? Well, longitudinal wave, and give examples of each. A longitudinal would be sound, and the vibrations are in the same direction, left to right, as the direction of energy transfer. Transverse waves, an example would be light, and the vibrations are at right angles to the direction of energy transfer. High frequency sound would have lots of waves per second, so they would be really, really close together. A low amplitude sound would be a really quiet one, so they wouldn't be very tall at all. And a low quality note we'll look at